Welcome to section 1-2. We're in Algebra 2. We're looking at algebraic expressions today, and we're going to give you that in definition form. And I figured the easiest way to start is to get the vocab out of the way first. So let's start there. Blank is an expression formed by repeated multiplication. Okay, repeated multiplication is this idea that we do a power. Okay, and a power, repeated multiplication, keep that in mind. Here's the idea. If I take 5 times 5 times 5 times 5, it's really the same thing as 5 being multiplied 4 times. So 5 to the 4th power. And this is the idea. Okay, blank is a letter used to represent a number. We call that a variable. Let's see if I can get my pen to work. We call that a variable. And a variable is something that you've already used in algebra. The most common ones are x and y, but you will start seeing a few more, and we're going to try and change just x's and y's. Okay. The things added, the parts which get added together, are called terms. So something like, if I gave you an expression that looked like 5x plus 4y. 5x is a term, and 4y is also a term that get added together. A sum means added together. A coefficient is the number that gets multiplied in front of a variable. Okay, so if I give you something, let me see something you've seen, like 5x squared, 5 is our coefficient. And I'm going to shorthand that a second. So it's the number in front. Okay, you can think of way more examples, but I just want to give you at least some ideas as we're going through. Okay. Next thing, an identity is a statement that equates to equivalent expressions. Equivalent means they're equal. So let's say I gave you this, 8x plus 3x equals 11x. These two together equal 11x. So because this is a true statement, we consider this an identity. Okay? Now there are two types of expressions. The first type is numerical. A numerical expression is only numbers, operations, and grouping symbols. And this is what we use order of operations for. So something like 2 minus 6 plus 3 cubed. This is called, whoa, that's supposed to be a 3. This is called a numerical expression because it only has numbers in it. So to contrast that, an algebraic expression is something that has a variable in it. So let me modify this. What if I said 2x minus 6 plus 3x cubed? And you'll notice all I had to do is add a variable. This was supposed to be a 6, but all I had to do is add a variable in order to make it algebraic. Okay? Last one. If I give you a c to the x, the c is what we call a base. Okay? So it's the base of my exponent, and my exponent is the x. The exponent represents the number of times the base is used as a factor. And it relates basically back up to 1a. What it says is basically I have c multiplied together, and I don't know how many times, but x number of times that it gets multiplied. So that means it's c to the x. And that's really all that they're trying to get you to see. Okay, now most of these should seem familiar. Maybe it's a wording that might be different, but I think you've seen all of these. So let's talk about the most important idea in Algebra 1, order of operations. Now, it may have been the most important, but I can also tell you it was one of the most difficult. And we will tend to make very little mistakes in order of operations. And so I'm going to heavily emphasize this for a while. Now, when we talk about order of operations, I believe you learned this phrase PEMDAS, or please excuse my dear Aunt Sally. Okay, and I'm going to put this kind of as we go through. Now, PEMDAS says first you do the operations occur within the, and the way you learned it was probably parentheses, which is fine. Here's the only problem. I want you to not just think of parentheses, but we call them grouping symbols in Algebra 2. And the reason is it won't always be parentheses. Maybe it will be brackets or something else. And so I want you to keep that in mind. Anything that groups them is what you do first. Okay, so we have the please. The next one was excuse, and that means we deal with the exponents. Okay, so please excuse my dear Aunt Sally. My dear means that we do multiplication. I don't know if I can fit multiplication and division, but here's the most important part as you read from left to right. Okay, so you start at the left and work your way through. My dear Aunt Sally is the same idea. First do addition, then do subtraction. Again, most important, from left to right. So let's do a couple of these as we go together. We want to start with our grouping symbols. In number 1, we need to group these, and we can do it at the same time because there are 2 grouping symbols. So I'm going to rewrite, and in this section I want you to show all of your work. So 2 plus 2 is 4, so times 4 cubed, divided by 3 plus 1 is 4, so 4 squared. Now the question is, did I really need the parentheses again? And the answer is no. Once I've done the addition and subtraction, or the addition and subtraction with inside, those are really considered multiplication symbols now. Okay, but we've done our P. Now let's talk about exponents. We always do our exponents first, and you read them from left to right. So 4 cubed is 64. So I have now 4 times 64 divided by 4 squared is now 16. Now I'm left with multiplication and division. And so I do them from left to right. So the first one I come to is multiplication. So this is what I do first. So 4 times 64 is 256. When you divide it by 16, now I can do the division. You end up getting 16 as your answer. And we're going to start tomorrow basically with a warm-up doing order of operations. Let me tell you, it's okay to make mistakes, but unless you show your work like this, I can't help you find those mistakes. Okay? Let's do this thing again. Parentheses we see first, but within parentheses, I need to do my exponent. So I'm going to do my exponent first. So 5 squared is 25. Okay? Now I'm going to do my parentheses. So 25 minus 10 is 15 divided by 5 squared. Now I'm going to do my exponents. So I'm going to do 5 squared is 25. So 2/5 plus 15 divided by 25. Now, this, I have to do division before I do the addition. But let me show you a different key. Because I already have a fraction, I'm going to make this 15 divided by 25. And whether I write it as a fraction or I write it without, it's still division. So I can take this fraction and reduce it. And what I end up getting is 2/5 plus, if I divide both of these by 5, 15 divided by 5 is 3. 25 divided by 5 is 5. So 2/5 plus 3/5 is 5/5. And we're not going to leave our answer like that. We're going to write our answer as 1. And I love this one because it makes you think a little bit farther, because if we can avoid decimal answers, we always want to avoid decimal answers. Okay? Now, let's do one more. Number 3. Now, you'll notice there's this bracket here, but there's also parentheses inside. So we need to start on the innermost side first. So I'm going to start here. -2 plus +2, that's the identity. That means you get 0. Times 3 plus 14 divided by 7. Whatever our answer is, we're going to square it. All right. We see inside multiplication, addition, and division. Well, we have to do multiplication and division first. And if I read from the left, 0 times 3 is 0. Plus, I see division, so I can do that. 14 divided by 7 is 2. And I still have to square that. Well, 0 plus 2 is 2. 2 squared makes 4. That one's a little bit trickier, and I like it. But again, I picked all of these because I like them. Okay, so order of operations, I am going to make you for this section, for this chapter, show all of the work that you've got. Because unless I see that, I can't help you fix the mistakes. All right, let's keep moving. Let's do a little bit more review. In number 1, this writing expression with exponents, that is basically saying instead of the repeated multiplication, show me the exponents. Well, I have 2a and it's multiplied 3 times. So instead of saying 2a times 2a times 2a, I'm going to use the parentheses because there's 2 quantities, and I'm going to say 2a cubed because it's multiplied 3 times. The x plus y is being multiplied twice, so I'm going to say x plus y squared. And all we're trying to get you to do is to say, why would we write it 3 times when we can easily just say cubed? Second one, -6 is being multiplied 4 times. We need our parentheses around a negative, so it's -6 to the 4th power. Okay? On the back side, if we want to evaluate, evaluate means plug it in. Okay? So every time we see a y, we're going to put a -5 in. Because it's negative, you need parentheses so that your calculator can help you actually plug it in. So -6 gets multiplied by -5 squared, minus 11 times -5 plus 34. Now in this case, the parentheses don't really mean parentheses, they mean multiplication. And so I'm going to look at exponents first. Exponents, -5 when you square it is a positive 25, and that's why the parentheses are important. Minus 11 times -5 plus 34. Now this is multiplication and this is multiplication. Okay, so we can do that at the same time. -6 and 25 is -150. 11 times -5 is -55, but if I am subtracting it, that means add 55 and then add 34. It's all addition, and addition is commutative, so add it up, you get -51. Okay? Second one, again, plug in a 3 for every y. So 2 times 3 squared and 3 minus 10. Well, this is parentheses, which actually means do something with it. So this says take 2 times 3 squared and multiply it by a -7. Let's do our exponents next. 3 squared is 9. I'm going to move this over here. So 2 times 9 times -7. Multiplication is commutative, so just multiply them together, get a -126. Okay? Now, I'm going to do the combining like terms with you next, and then I'm going to wait on the story problems, because we're going to make our story problems a little bit different this year than anything you've ever done. Scary, I know. And I know you love the story problems, so that's something I want to introduce in class tomorrow. So let's look at combining like terms. And then I promise you I'm going to stop the video. It'll be a nicer, shorter day so that you can actually see the type of things we want to see for story problems. Okay? Now take a look. Combining like terms. Like terms have to be the same variable and the same exponent. So let's look. Now my way of doing this without showing a ton of work is using circles, squares, and triangles. Let me show you what I mean. I'm going to start with the highest exponent, which is a cubed. I have 2a cubed and I have 5a cubed. Because they're both a cubed, I can add them together. 2 plus 5 makes 7, so I have 7a cubed. That's the first part. Now I'm going to look at the a squareds, and in order to show that they are alike, I'm going to use a box this time. Now I'm going to include the negative. This is negative 6a squared and a positive 3a squared. So negative 6 plus 3 is negative 3, so negative 3 of those a squareds. We have a negative 6 hanging out in the back. I want to make sure this actually looks like a squared. I apologize for that, my marker. And this is our final answer. And by using just circles and squares, that's enough for me to see that you know what a like term is. Okay? Now, I'm going to skip to number 3 because I don't have parentheses. I have 14 x's and 5 x's, which means I have a total of 19 x's. I have negative 6 y's and a positive 13 y. So negative 6 and positive 13 is a positive 7 y's. And I'm hoping that you're finding this really nice. Last one, let's distribute and then we'll do the same thing. 2 times y is 2y. 2 times 5 is 10. I'm going to take this negative 3 and distribute it. Negative 3 times y is negative 3y. Negative 3 times negative 9 is positive 27. And by taking the negative with it, it already accounts for the subtraction inside. So now let's add like terms. 2y and negative 3y is a negative y. Please don't put the 1 in front, but if you need it right now, I'm okay with it. By the end of chapter 1, we'll have to get rid of it. 10 and 27 makes a positive 37. Okay? And what you've noticed is anything that has a variable, this is going to be shocking to you, but we call this a variable term. But it's something that doesn't have a variable, like this negative 6 or the 37. These are called constant terms. And the reason we call them constant terms is a variable will never affect that number because nothing will ever get plugged in. Okay? So this is kind of the basis of stuff that we're doing in chapter 1. I hope this feels a lot like a review day to you. What's going to be a little bit more difficult is our story problems. But we are going to give you a process, and we're going to do this in class, which shows you how to work a story problem out, and we're going to relate it back to some of the writing stuff that we do in other classes as well. So this is it for section 1-2. I hope so far you're feeling okay with the videos. If you had a question though along the way, please make sure you write it down, highlight it, circle that question, because I will go through questions from the notes tomorrow in class. So thank you for watching.